Hey guys, this is Mrs. Chabot. I hope that you are enjoying the videos provided by Elaine Martin Gay on MyMathLab. But before you start section 2.4, which is linear inequalities, I just want to take a few minutes to introduce interval notation before you get started on that lesson. So the lesson will be using interval notation, which you are going to be using for the remainder of the semester. And if you continue in mathematics, you will continue to use interval notation. So you're probably already familiar with working with inequalities from previous classes, such as x is less than 3. So you may have seen it in set notation, right? The set of x such that x is less than some number a. And the way you'd graph that on the number line is you'd plot whatever the number a is. If x is less than a, that would be everything to the left of a. Now, in the past, to show that x cannot equal a, you would have used an open circle, right? So we'd use an open circle to show that a is not included in the set, which you still can, but leading up to interval notation, instead of an open circle, we're going to use a parentheses facing the shaded part. Now, just bear with me for a moment. The way we'll write this in interval notation is we write parentheses, negative infinity, comma, a, close parentheses, and I'll get back to this in a few moments. All right, now to look at the set of x where x is greater than a, you'd plot a on the number line, and if x is greater than a, we shade everything to the right. And again, since x is strictly greater than a, in the past we'd use an open circle to show that it's not included, but now we'll use a parentheses facing the shaded part. And in interval notation, we'd write parentheses, a, comma, infinity, close parentheses. Moving on to the next set, x is less than or equal to a. We plot a on the number line. If x is less than a, which way do you shade? That's right, to the left. And in the past, how would you show that x equals a, that a is included in the set? So in the past, you used a closed circle, which you still can, but for today, and in this section, you're going to use a square bracket facing the shaded part. In interval notation, you're going to write negative, parentheses, negative infinity, comma a, and then a square bracket. For this set of x where x is greater than or equal to a, again, plot a on the number line. If x is greater than a, which way do you shade? Okay, good, to the right. And x can equal a, and we can use a closed circle or a bracket facing the shaded part. In interval notation, use bracket, a, comma, infinity, and close parentheses. So notice this interval notation that we're using. You don't want to just memorize this chart. You want to see where this is coming from based on what the set looks like on the number line. So notice we're describing the shaded part from left to right. So you always read the number line from left to right, just like you read a sentence. So here, the set is everything to the left of A. So it's everything here. So if it's going forever to the left, I would say it's starting at negative infinity, and the set ends at a. Okay, so that's why we write negative infinity to a. When we're shading to the right, if I'm reading it from left to right, I would say the set starts at a, and if it goes forever to the right, I would say it ends, so to speak, at infinity. So my set is going from a to infinity. Okay, so hence the a to infinity here. Same idea for the equals to. So that's where these symbols are coming from. And notice it's really important to note that when you're including the endpoint in your set, you use a square bracket adjacent to that endpoint in the interval notation. Okay, so let's put that together with these next few sets. The set of x where a is less than x, which is less than b. So you plot A and B on the number line. So what does this mean if A is less than X, or X is greater than A, but X is also less than B? So you might recall that means that the set is between A and B. Okay, so using our endpoints here, if A is strictly less than X and X is strictly less than B, A and B are not included, so we use parentheses, right? We're skimming just up to A, but A is not included, and the set is coming just up to B, but B is not included. So it would be parentheses, A, comma, B, parentheses. Okay, the set of X where A is less than or equal to B, which is, A is less than or equal to X, which is less than or equal to B. Plot A and B. Again, X would be between A and B, but X can equal A. So what do we use to show that X can equal A? We use a square bracket. And X can equal B, so we use a square bracket. Okay, so we use the brackets when we're including those endpoints in our set. So that would be bracket A, comma, bracket B, bracket, excuse me. All right, on the next one, the set of A is less than X, which is less than or equal to B. So you plot A and B, shade in between. Okay, X is strictly greater than A, so make sure you have a parentheses at A, but X can equal B, so we show that using a square bracket. So in interval notation, reading this from left to right, our set starts with a parentheses at A, and then it ends at B with a bracket. The set of X where A is less than or equal to B, the set of X where A is less than or equal to X, which is strictly less than B, we'd plot A and B again, shade in between, and since A is less than or equal to X, we use a bracket to show we're including A, and X is strictly less than B, so we use a parentheses to show that we are not including B. Reading that from left to right, our set starts with a bracket at A and ends at B with a parentheses. Okay, and then the last type that I'd like to talk about today is this set of real numbers. So if X is any real number, we'd shade the whole number line. Well, how do I describe this from left to right in interval notation? Well, if it's starting, so to speak, forever to the left, my set would start at negative infinity, and it would end at infinity. Notice we only use brackets to show that we're including an endpoint. So whenever you have infinity and negative infinity, those have parentheses adjacent to them. So this is how we'll always write the set of real numbers in interval notation. Parentheses negative infinity, comma, infinity, close parentheses. All right, so from here, you're going to go back to your MyMathLab lessons. In section 2.4, they'll have some examples with interval notation, and then you'll review solving inequalities. When you solve inequalities, you'll solve them just like you have in algebra in the past, but you're going to write your final answers in interval notation. Okay. All right, I hope you have a good day.